Hello everyone, welcome to a new video on electric vehicle technology. In today's video, we are going to discuss about vehicle mechanics. So first of all, we are going to deal about what are the laws of motion governing the vehicle mechanics. So to give a design thinking insight, first let's understand how can EVs provide smoother acceleration for passenger comfort. We know that electric vehicles work on the principle of physics. So every vehicle is being ruled by the law of motion, which explains how the vehicle starts, moves, stops, and keeps us safe. The same way, an electric vehicle is also being explained through this law, Newton's law of motions. This electric vehicle is used in a vast manner because it provides clean energy, sustainable future, and provides better efficiency and is a good source of smarter mobility. So let's discuss in detail about the basic laws that governs the law of motion. First, Newton's first law, which is the law of inertia. So Newton's first law states that an object at rest stays at rest and an object in motion stays in motion unless acted upon by an external force. So, if there is an external force we apply on a body, the vehicle or the object moves. For example, when an EV is moving, it continues to move at the same speed in a straight line unless we apply brakes or another force. So, until we give an extra acceleration, the vehicle will keep moving on the same speed. Also, when it is at rest, until we start the vehicle and give acceleration, the vehicle will not move. So the passenger feels a jerk forward when the EV suddenly stops. That is what we call it as Newton's law of inertia. Now, Newton's second law that governs the law of motion, which is the law of force. The object on an object equals its mass multiplied by its acceleration. So Newton's second law states that force is equal to mass into acceleration, which is called as the law of acceleration. More force from the motor produces more acceleration. If the EV is having more mass, then it needs more force to achieve the same acceleration. So hence we conclude more motor power leads to more acceleration, and these more motor power can be provided with the help of battery, which is the source of energy that provides force to the EV. Now let's look into the Newton's third law. Newton's third law states that for every action there is an equal and opposite reaction, which is the law of action and reaction. For example, in terms of EV, when the EV pushes the road backward, the road pushes the EV forward. So this can be understood when we apply brakes. For example, force on road backward is the action means, then force on EV forward is the reaction. So when we give any sort of force in one direction, it experiences another sort of force in the opposite direction. So in real world EV, this Newton's law is used for different mechanics. First law is used for moving the vehicle. Second law is used for starting the vehicle. First and third law is used to stop the vehicle. And the third law is used for traction. And finally, the centripetal force along with the friction is used for turning the vehicle. So understanding the basics of these laws will provide a good understanding about the vehicle mechanics. Now, based on this law, what we have studied now, here is a crossword puzzle. Take a screenshot of this puzzle, solve it, and do comment your answers in the comment. So it is a crossword puzzle based on the content we have discussed. So the key conclusion for this topic is that Newton's law explains how EVs move, accelerate and stop. So with the diagram we have found how this law of mechanics deals with every movement and rest and braking part of the EV. So physics and technology together drive EV performance. And with the help of this design thinking aspect, we help to create a better and user-centric solutions. And this understanding will make better usage of EV, leading to a sustainable mobility. So with this, we conclude to the end of the session. Hope this topic is understanding to you. We'll meet in the next topic. Thank you. Thanks for listening.